Let's take a look at the first pretty simple problem. 2x plus 2. This is in the numerator of a fraction and the bottom is a 2. Now, when you see a fraction like this, a fraction bar, this means division. So what you're doing is you can envision like invisible parentheses around the numerator. So this 2x plus 2 as a quantity, after you calculate it, then you divide by 2. So if you put in x is equal to 4, you would calculate the top with x is 4, and then you would divide that by 2. Whatever you got as an answer, you divide by 2. Now, how do we simplify this expression? At first glance, it appears there's nothing we can do. I don't see any x's I can cancel on the top and the bottom. Also, I look in the numerator, 2x plus 2. These are different terms. Like this is an x term and this is no variable. So these are unlike terms. So I can't combine them. And I can't really do anything with this. And then but you say, oh, I have 2's everywhere. What can I do? So my advice to you is, if you think you are inventing new math, right? Because maybe you're kind of like trying to stretch a little bit and think, what should I do? But you feel like you're inventing something, stop, because you probably are inventing something. You're probably not thinking about it correctly. Let me show you the right way to attack this. We're going to redraw this guy. The 2 on the bottom we can't do anything with. But if you just cover everything up and focus on the numerator, I can factor out a 2, right? Because I have a 2 common to both of these terms. I do not have an x common, so I can't factor an x out, but I can definitely pull out a 2. And I'm allowed to do that because we've done factoring, and we know that it's perfectly legal to do. So it all has to stay in the numerator, just like this stuff is in the numerator, but we can factor here. Now, 2 times what is 2x? Well, I need to have an x here. A plus sign needs to go here. And then 2 times something is going to give me this 2. I need to have a 1 here. Take a moment and verify that the numerator here is the same thing here. If I distribute in, that'll give me 2x. If I distribute in, that'll give me a positive 2. So this, even though it looks very different, calculates to be exactly the same as what you have started with. So these are equivalent. That's why we have an equal sign. Now what do you do? Well, let me go ahead and rewrite it over again so we can not make any mistakes. 2x plus 1, and then a 2 on the bottom like this. Now, it looks a little bit funky, but what I want you to do is remember, when you have, let's change it a little bit. Instead of this stuff, what if I did it like this? 2x, and on the bottom, a 2. How would you do that? Well, you would say, these guys are multiplied in the top. We multiply by 2, and then we divide by 2. We have a common 2 in the top and the bottom, so we can strike, cancel, and what is left over is x. This is what we've done before. The only difference between this and this is that instead of just a single x here, we've replaced it with a larger, more complex term, the parentheses term here. But you need to start viewing math, instead of like looking at every little letter and every little number, you need to start looking at blocks of things and compartmentalizing it. What this is 2 times something, which is a complex thing, but it's still an object, and then you divide by 2. This is 2 times something, in this case it's an x, divide by 2. We're allowed to cancel things as long as everything's being multiplied in the top and the bottom. If I see commonality, I can cancel. Everything is being multiplied in the top, it's just the thing I'm multiplying by is more complex, but it's still 2 times something. This allows us to cancel the 2's because this situation is the same situation that we have here. It's just instead of x, we have a more complex thing, but it's still multiplied. We're taking this times 2, divide by 2. I can divide away the 2's, leaving 1 behind. When you cancel like this, you're leaving 1's behind, and all I have left at the end of the day as a final answer is just, well, we could leave it as parentheses x plus 1, but we can remove those parentheses and just call it x plus 1. That is the final answer. When I put a bracket like this, the bracket doesn't mean anything. It just means I'm circling my answer. I don't want to draw a gigantic circle, so I just put the little bracket there. Now, what does this actually mean? It means that even though this looks completely different than this, these two things are the same. Just like fractions can look different and be the same thing. How can we check it? Let's put a number in for x. Let's put in 3. So 3 plus 1 is 4. Now let's put in 3 here. Well, if I put 3 in here, 2 times 3 is 6, and then 6 plus 2 is 8. So I have 8 on the top and 8 divided by 2, it's 4. If I put a 3 in there, 3 plus 1 is 4. So I get the same thing. If I put a 3 in here, 6 plus 2 is 8 plus 2 is 4. 3 plus 1 is 4. If I put negative numbers in, positive numbers in, decimals in, if I put whatever I want in for x and calculate using this or using this, I get the same thing. They are the same thing. Now you can start to see why we spend so much time simplifying things. Because if this term is inside of an equation later, then it's probably going to be simpler for me to put it into this form to solve the equation, because it's much simpler to use this to solve something than it is to use this ugly thing with fractions, because not only did you get rid of the 2's, but you also got rid of the fraction bar. And so it's much, much easier and simpler to work with, later on when we use this stuff for real things. All right, here's something maybe a little more familiar. 2 times x times y over 4 times x. All right, let me rewrite it. 2 times x times y over 4 times x. Remember how we handled this kind of thing before. We see an x in the top to the first power and an x in the bottom. So we can completely cancel this x with this one. They divide away and give you 1, and the 1 disappears because anything times 1 it doesn't do anything. And then I have these numbers, and I can divide the numbers by whatever I want. I'll divide by 2. 2 divided by 2 is 1, and 4 divided by 2 is 2. What do I have left? I have 1 times x. I never really write the leading 1 as a coefficient, times y. And this x is actually gone, so really I have only 1 times y. I just leave it as y. 2 times, and both of these are gone, so it's going to be over 2. So the answer here is y over 2. So again, this is very much simpler than this. So if I had an equation, let's say I'm solving for some gravity around a black hole, and something like this is in my equations. Well, this is ugly, so I'll make it simpler, and I'll use this and this to continue solving my problem. This is way easier to work with than all of this junk. Half of math, half of discoveries that we find later on in math is just figuring out how to simplify a problem and make it solvable, basically. All right, let's take a look at also something very familiar. What about 10? A times b squared over 5b. So let me rewrite it. 10 times ab squared over 5 times b. All right, I have a b in the bottom and 2 b's multiplied times itself, b times b in the top. I will cancel this entire b with one of these b's, leaving one of them left behind. And then in terms of the numbers, I'll divide by 5. 5 divided by 5 is 1, 10 divided by 5 is 2. And the answer I get on the top is 2 times a times b to the first. So 2 times a times b. And really on the bottom, all I have is a 1 here, right? There's just a 1 down here because it's 1 and these strike away to give me 1. And so really all I have is 2 times a times b. And this is the final answer, 2 times a times b. I think all of us would agree that this is exactly the same as this, but it's way simpler. So if I was solving, I don't know, some equation about the electrons in an aluminum atom, and this kind of thing showed up in my equations, well, that's going to be hard to work with. But if I change it to this, which is equivalent, then suddenly everything's easier to deal with. Because we know they're the same thing, let me just choose to work with the simplest thing I can. All right, let's take a look at 6a plus 3, all divided by 3. Now again, it looks like I can't do anything because I cannot combine these terms in the top. So, but what I do see is I am able to factor something in the numerator, right? What is, the denominator only has a 3. I can't really do anything with that. But what can I do in the numerator? What is common to this? Well, the a is not common to both, but a 3 is, both of these numbers are divisible by 3, so I can factor out a 3. And then 3 times something is 6a. I have to have a 2a here. 3 times 2a is 6a. And then I have to have a plus sign. And then 3 times something is 3. I have to have a 1 here. Double check that when you multiply, you get this. When you multiply, you get this. Now what I'd like to do is rewrite it. 3, 2a plus 1, all divided by 3. I don't like striking through, immediately, because then you're not sure what I'm doing. But anyway, you have 3 times something, and then you have 3 on the bottom. So it's just like that earlier situation. I can cancel some of these b's because they're present in the top and bottom. I can simplify the 2 and the 4 because they're present in the top and bottom, and everything in the top is multiplied by the stuff in the top, and everything in the bottom is multiplied in the bottom. So I can simplify or strike through the 2's as long as that's the case. Well, here it's the same thing. It's 3 times something, so it's still multiplied in the top, and then there's a 3 in the bottom. So I'm free to cancel those or divide them away, giving me 1 left behind, however you want to think about it. So what you really have left over is just 2a plus 1, and I can drop those parentheses because I basically can't combine these any further. Once I cancel these, they just disappear and leave a 1 behind, 1 times, and then a 1 on the bottom, so they basically disappear, and 2a plus 1 is just the final answer there. All right, let's take a look at 4b plus 6, all divided by 2. And you ask yourself, I can see that I can factor something out of the top. What is divisible in terms of the numbers? I can divide both by 2. So I'll factor out a 2 on the top. And what do I have to have here? 2 times something is this. I have to have a 2b, because 2 times 2 is 4, and then the b multiplies to give me 4b. Then a plus sign. 2 times something is 6. 2 times 3 is 6. So that is the factored form, and then I have a 2 on the bottom. So let me rewrite it. 2b plus 3. And on the bottom, it'll be a 2. And then the 2's, because I have something, every term in the numerator is multiplied. It's just a giant term here. I can cancel with what I have on the bottom. The 2's cancel. And so what am I going to have left over? It's just going to be 2b plus 3. And I can drop those parentheses because I've basically done, I mean, you need the parentheses to show that it's multiplied by something, but once you cancel and it's gone or it reduces to a 1, then I can just remove the parentheses because it served its purpose. All right, let's switch gears back to 21a b to the power of 2 over 14a b to the power of 3. Now what I'd like to do before I do anything else is rewrite it so I'm not marking up my original problem. ab squared and then 14ab cubed. Now what do you think we do? Well, I have a single a on the top and the bottom so they can both strike away and cancel. Again, what's really happening, they're dividing away, giving you 1, which sort of disappears there. I have 2 b's on the top and 3 on the bottom, so I'll cancel both of those b's with both of 2 on the bottom, leaving 1 b left behind. And then for the numbers, 21 and 14, I can divide by 7. 21 divided by 7 is 3, and 14 divided by 7 is 2. So the numbers reduce to the fraction 3/2. So what am I going to have on the top? 3. And it looks like I've struck through everything else, so only a 3 is on the top. And then a 2 on the bottom. There is no a, b to the first, so it's just 2b. That's all there because b to the first is there. So it's 3 over 2b. And that's the final answer. All right, let's squeeze one more in this because I do have quite a few problems here. What about 9y minus 3 over 3? All right, again, I can't cancel anything immediately, but I see that I can factor a 3 because this is divisible by 3 and this is divisible by 3. So just factor out a 3. 3 times something is 9y. I need a 3y here. When I multiply this back, I get 9y. Then 3 times something is 3, so there must be a 1 right here. And on the bottom, I have a 3. And once I put it into this form, I can see that I have a 3 multiplied by something and then a 3 on the bottom. I can just divide those 3's away or cancel them, however you want to think about it. And all I'm going to have left is 3y minus 1. 3y minus 1, that's the final answer. All right, we're past the halfway point. Let's change gears a little bit. And let's say we have something like 5x squared plus 10, and we'll divide that by 5. Now, it looks a little bit more difficult, but it's not. This x squared does not change anything or make it more difficult. Let's see what we can do. Well, on the bottom, there's nothing I can do. That 5 just has to stay there. But in the top, I can pull out a 5. Both of these are divisible by 5. I cannot pull out any x's because I don't have any x's in this term, so I need something common to both terms. So when we factor out this 5, what do we get? 5 times something is x squared, so here has to go in x squared. This times this is x squared. Then 5 times something is 10. That has to be a 2. 5 times 2 is 10. So let me go ahead and just rewrite it. 5x squared plus 2 over 5. And what do you have? Now this 5 cancels with this 5. And all that I am left with at the end of the day is x squared plus 2. And that's it. I can take away the parentheses, and that's the final answer. And of course, this is much simpler than this, but they calculate to the same exact thing no matter what value of x you stick in there. All right, what about 8 times a squared minus 12 divided by 12? All right, what do we do here? Well, I'm not totally sure, but I know that these are both even numbers, so I can definitely factor out a 2. But then I start thinking harder. Is there anything bigger I can factor out? What can I divide in here? I actually can pull out a 4 because this is divisible by 4 and so is this. You want to factor out the biggest thing you can. I cannot pull out any a's because I don't have any over here. So 4 times something is 8, 4 times 2 is 8, and I need an a square here so that when I multiply this in, I get 8a squared. Then a minus sign. 4 times something is 12, 4 times 3 is 12, and all this stuff is in the numerator. On the bottom, I need a 12. So let me rewrite what I have. 4, 2a squared minus 3 over 12. All right, so what do I have? I have numbers here. Now notice in all the previous examples, I struck the 5 with the 5. I struck the 2 with the 2. I struck the 3 with the 3. Here, I had a similar situation where I didn't just strike them out. I had to divide by, I mean, basically you're doing the same thing. When you have the same number, you're dividing the top by 2 and the bottom by 2, and you're just getting a 1. Dividing this by 3 and this by 3, and you're getting 1s. What can I divide top and bottom by here? Divide by 4. 4 divided by 4 is 1. 12 divided by 4 is 3. Now in the top, technically you have 1 times this parentheses, but that's not going to change anything. In the top, all you really have left is 2a squared minus 3. And on the bottom, you have the 3. Again, really you have this times 1, but you know anything times 1 is just itself. So I can just drop the times 1 and I can leave it like this. So 2a squared minus 3, all divided by 3. All right, making good progress. What about 10b plus 15? And I'm going to divide all that by 25. What can I factor out on the top? Well, I can divide both of these numbers here by 5. So I'm going to pull 5 out. What do I need to finish it up? 5 times something is 10, so it has to be a 2, and I also need a b here when I multiply to give me 10b. Then 5 times something is 15, that's just 5 times 3. So let me rewrite what I have. 5, 2b plus 3 over 25. And I see that I have a 5 and a 25. I can simplify now. That's why I factored it out to begin with. I can divide by 5. 5 divided by 5 is 1. 25 divided by 5 is 5. So what do I have left? Yes, it's 1 times this, but that's not going to do anything. So just drop the parentheses, 2b plus 3. And on the bottom is just a single 5. So it's 2b plus 3, and on the denominator, it's just a 5. All right, just a couple more problems, and we will call it a day and be done with this. This one I want you to pay very good attention to, very close attention to. 3y cubed minus 9y over 3. Now, of course, we're going to have this 3 on the bottom, but what can I factor out in the numerator? Well, for the numbers, I can divide these both by 3, so I can pull out a 3. And as far as the letters, I have a single y and 3y, so I can only pull out one of them. I have to pull out what is common, the maximum common to both. So I'll pull out a 3 times y, and what do I have here? 3y times something is this. It has to be y squared, because 3 times this is 3, and y times y squared is y cubed when you add the exponents, minus. This times something is 9y. You have to have a 3 there. 3 times 3 is 9. Y times this is just going to give you the y. So that is the factored form. So it's 3y, y squared minus 3, and then 3. Now notice what's going on here. Just like in this easier problem over here, it was 21 times a times b squared. So we had lots of things multiplied together, and then 14 times a times b cubed. And you can cancel as much as you want when everything's multiplied on the top and the bottom. Here it's 3 times y times a bigger thing, and I see a commonality of a 3 and a 3, but I can't cancel any y's because there's no y's down there. So what I have for my final answer is just y parentheses y squared minus 3. That is about as far down as I can go. Y times y squared minus 3. All right. So you see, this is the first problem where we factored out a number and a letter that was common, in this case a variable. So let's take a look at 14. X squared minus 10 times x, all divided by 4. So what am I going to factor out here? What is common to 14 and 10? What is the biggest thing I can divide by with 14 and 10 right there? Well, I know I can divide by 2. I can divide both of them by 2. And I have an x and an x squared, so I can pull out a single x as well. And on the bottom, I'm just going to have this 4. Now, 2x times this times something is this. You have to have a 7x there. 2 times 7, 14. X times x, x squared. Then 2x times something is this. 2 times 5 is 10. And the x is coming along for the ride. So this is the factored form. And then I don't think I'm going to confuse you too much now that I have it into this form. I can simplify the numbers by dividing by 2. 2 divided by 2 is 1. 4 divided by 2 is 2. And then finally, the final answer will just be an x on the outside, 7x minus 5 on the inside. So x, 7x minus 5. Oops, I made a mistake myself. In the bottom, I have a 2. Forgot about that. So in the numerator, you have 1 times this stuff, but the 1, you never have to write a coefficient of 1. So you just have this, but in the bottom, you still have that 2. All right, here's our very last problem, and we are done. Let's take a look. 6a to the 4th plus 10a to the 3rd power, and the denominator is just a 4. So we know, or we suspect, or we hope, we can factor that numerator and make it simpler, but that 4 is going to remain in the bottom. 6 and 10, what can I divide by? I can divide by 2, so I'll pull out a 2. That's what I can pull out of both. A to the 4th, a to the 3rd. The largest thing common is 3 of those a's, so a to the 3rd. And then what goes on the inside? 2 times 3 is 6. And to make an a to the 4th, I think I need another a here, so they add to give me a to the 4th. And then I need a plus sign. And then 2 times something is 10. 2 times 5 is 10. And a cubed is already there. So it looks like this is the factored form. And then I can say, well, I have a 2 and a 4. I know I can now simplify that. 2 divided by 2 is 1. 4 divided by 2 is 2. So I'm dividing top and bottom by some common number. And so what am I going to have? The 1 can just kind of float off. It's multiplied, but it doesn't affect anything. A cubed, parentheses, 3a plus 5, close parentheses, all divided by 2. So a cubed, 3a plus 5, all over 2. So again, take a look at where we've come from. We've come from pretty simple little problems like this, you know, very simple things to factor. And then we've moved on gradually so that now we have multiple exponents, multiple letters, and things like variables that we have to factor out and try to cancel. Right? So again, if you think you're inventing math, if you look at something like this and you're like, oh, maybe I'm supposed to add these somehow, but in the back of your mind, you know you can't add these because these are unlike terms, and you start trying to do stuff that you don't think you can do, but you aren't sure, then you're probably inventing some new math that's not real, it's not true. So if you feel like you're reaching like that and you're not sure, then you probably are. You're probably inventing something that you want to do, but you can't. So instead, do the things that you know you can do. Right? We know we cannot add these because they're unlike terms, so don't do it, right? But you know that you're allowed to anytime, you can always reverse distribute, which is factor. You know, a lot of people say in the beginning, why do we learn how to factor expressions? Who would ever want to invent a parenthesis and pull stuff out? This is why. Because I can start with something like this that looks ugly, and I can end up with something, well, maybe that doesn't look quite simpler, but look at something like this. I can start with something like this that looks ugly and end up with something a little simpler. I don't have a fraction anymore. I get rid of some of the numbers. They're a little bit smaller. And the only reason I can do that is because I can factor at the top and then cancel something. So why do we learn to factor? One of the reasons is to simplify expressions so that we can solve our equations. If you're dealing with an equation with a very large term, the first step is to try to simplify it, make it simpler so that you can solve it. So all of these steps, learning how to distribute, learning how to factor, learning how to cancel, learning to deal with exponents, they all build up so that we have all of these tools. In a few lessons, we start to solve equations, we'll be able to conquer more advanced things. That's what we're doing. So solve all of these yourself. Follow me on to part 2. We will crank up the complexity a little bit and give you more practice with dividing and simplifying expressions. Learn anything at mathandscience.com.